So amplitude of a wave. This first topic. Second is velocity of a wave. So we'll discuss on these two, amplitude and what is velocity of a wave. Okay. Right. So first is amplitude. I am writing the definition. I will explain. Amplitude. So in physics, in the waves, we will use this notation small d for amplitude. Okay. And the SI units for amplitude is meters. So we have to write down meters here. Right? Okay. So what is amplitude? It is the maximum distance. It is maximum distance. It is maximum distance. It is maximum distance of a wave from mean position. From mean position. So this is the definition of which is amplitude of a wave. Okay. Or we can write in another form the same definition. Right? It is a distance. It is distance from crust or trough from mean position. From mean position. So this is the definitions of amplitude. Maximum distance of a wave from mean position, or it is distance from crust or trough from mean position, right? Now, suppose if you take this wave like this, so this wave already you know, this is the form of the wave, right? So this point is known as crust, these 2 points, maximum distance from the mean position. So this is the displacement y, this is time axis t, okay, right? So this is known as mean position. So in the mean position, the particles will not vibrate, they are at rest position. So this line is known as mean position, because as the particles are at rest position, right? So here particles are vibrating here. When you take a particles on the wave, they are vibrating. So they are vibrating in the perpendicular direction of propagation, hence it is known as transfer wave. So already in the previous videos already explained what is transfer wave, right? So the maximum point, that is, this is known as peak point. These peak points are known as crust here, A and C. This is the B and D. If you take continue this curve, you will get D here, right? So this B and D are known as trough here, right? So what is amplitude? It is the maximum distance of a wave from mean position. So the maximum distance of a wave is this one. So this is the maximum distance. So this distance is known as D, right? So this is known as D, maximum distance from mean position. This straight line is the mean position. From mean position, so your maximum distance is D. This one also you can say this is D, maximum value. This is maximum value is D. So maximum position, the maximum distance from the mean position, right? So this is the maximum distance, you can say this one. So this is the wave here, right? So this is the maximum distance from mean position, right? This is D. So this is D, okay. So maximum position from the maximum distance from the mean position, that is known as amplitude, okay, right? And one more definition, it is the distance from crust or trough from mean position. So this is the point crust, this is the point trough here. So distance from this crust point to the mean position, distance from trough point to the mean position is known as amplitude, right? So again I will show in the figure. So what is amplitude? So if you take this curve, right? So this is the standard form of the curve, okay, right? So this is displacement and this is time, right? So this line is known as mean position. This line is known mean position. Means the particles are at rest here. particles are at rest, that is known as mean position. So particles are at rest is a mean position. Okay. Okay, there are undisturbed position also. You can say one more word is undisturbed. I means the particles are not disturbing, they are rest positions. What are the particles which are there? They are rest position, right? So what is amplitude here? So these are known as crust points on the curve AC, you can take, and this is BD. What is crust and trough here? Crust points are maximum points on the upward curve from the mean position. This trough are downward maximum points, right? Now, what is the definition of this amplitude? Maximum distance, this one D. This is D, maximum distance from the mean position. So, if you take point here, you can find the distance here, this distance, right? This is D, D1 you take, but this is more. This value is more when compared to this value. So, you want the maximum distance. So, this will be the maximum. If you take any point on the curve, if you find the D value, this will be the maximum. So which is maximum? The crust point and the curve, if you find the distance from the mean position, that will be the maximum value. So that value is known as amplitude. Here also. So from the crust point, if you find the value from the mean position, that is known as D, that is amplitude. Here also, if you find the distance from the mean position to the trough point, these are known as trough points. If you find the distance here, this is trough point. So all these are known as amplitude. So this is a definition, right? The maximum distance from the mean position or the distance from the crust to the mean position or trough to the mean position. So this is known as amplitude. And one more thing is, this distance you have to take on y-axis here. So this y is known as displacement. So y is known as displacement. Okay. So on the y-axis you are taking this value. So your amplitude value you have to take on y-axis, not on x-axis. X-axis is a time scale, right? So this amplitude you have to take on y-axis, right? So this is regarding amplitude. Okay. Now what is second one? Second one is velocity. Velocity of a wave. Second one is velocity of a wave. Velocity of a wave. Right? So what is velocity? Already you know the standard formula for velocity. Velocity is distance by time. This already we know. Very standard formula, distance by time. But in wave, what is the distance here? This displacement. This is time axis t, right? A curve is like that, like this, right? So what is distance here? We are taking this one from, these are known as crust points, maximum, points on the curve are crust points. These are trough points, maximum in the downward curve, right? This is not, if you take this as C, this B and D, right? So what is distance here to the between two crust or two troughs here? This is known as lambda. Lambda is known as wavelength. So for the distance you can replace with lambda here. So this is lambda. So whenever the motion object is in a straight line, there you are talking when object is moving from A to B. So here you are talking in terms of distance, right? In terms of time t. But here in the wave, the distance is this lambda wavelength. Here will specify the distance in terms of lambda. That is the distance here, right? Between two crust or two trough. That is the wavelength here. Or what is wavelength? Length of the wave. Length of the wave is also known as wavelength. That is another form of definition. So here in the wave, here lambda is the distance. Whereas when the object is moving in a straight line, their distance is s here. In the wave, so s is proportional. When you are taking s there when the motion object is straight line, but here in the wave you have to take lambda. So you have to replace d with lambda. What is time? Time is time period. So what is time period? Already in the previous videos already explained about time period t. So whenever the motion object is in a straight line, your velocity is distance by time, s by t. But for a wave, this is for a wave, velocity of a wave, your distance is here, this is lambda, wavelength. Time is time period. So this is the velocity. Velocity of a wave is lambda by t. That is wavelength, lambda. This time is time period. Okay. So velocity of a wave is defined as ratio of wavelength to time period. Wavelength to time period. Okay. So this is a standard definition here. So for a motion of the straight line, v equal s by t. For a wave, it is lambda by t. Okay. Thank you.